Shall we proceed? I told you this is an important one. Integral of 0 to pi by 2 log sin x dx. Right. So let me take this as I. So I is equal to integral of 0 to pi by 2 log of sin x dx. Then I can also be written as integral of 0 to pi by 2 log of sin pi by 2 minus x dx. Why? Since integral of 0 to a f of x dx is equal to integral of 0 to a f of a minus x dx. Okay. So that is a property. So from this one, if I take I, so I will be equal to integral of 0 to pi by 2 log of cos x dx. Okay, log of cos x dx. So when I add these two, what will I get? 2I will be equal to integral of 0 to pi by 2 log sin x plus log cos x into dx. So 2I will be equal to integral of 0 to pi by 2 log of sin x plus, so log a plus log b is going to be log ab. So it is going to be sin x into cos x dx. Okay. So which implies 2I will be equal to integral of 0 to pi by 2 log of, see what I'm going to do is I'll multiply and divide with 2. So 2 sin x cos x divided by 2 times dx. So 2I will be equal to integral of 0 to pi by 2 log of sin 2x minus log 2 dx. Because 2 sin x cos x is sin 2x. So log sin 2x by log 2. Log a by b is equal to log a minus log b. Okay. Is that clear? No. So let's take this value. So what did we get? 2I is equal to integral of 0 to pi by 2 log of sin 2x minus log 2 dx. So I wrote the same thing again. There is nothing to copy. So it's the same thing. Now, how do we proceed with this? So 2I is equal to, can I write it as integral of 0 to pi by 2 log of sin 2x minus integral of 0 to pi by 2 log 2 dx. Can I do this? Right. What I did is I split it each term out. So what I'm going to do is I'll take this thing as I dash. Okay, let me call this as equation number 1. I'm taking this integral alone and I'll call it as I dash. So I dash will be equal to integral of 0 to pi by 2 log of sin 2x dx. Sure. So what I'll do is I'll try to put 2x is equal to b. When I do this, I'll get 2 times dx is equal to dt. Accepted? Am I right? So what will happen to the limit when x is equal to 0, t is equal to 0, when x is equal to pi by 2, t will be equal to pi. Is it right? So I dash will be equal to integral of 0 to pi log of sin t into dt divided by 2. So this will be equal to half of integral of 0 to pi log sin t dt. Clear? I hope it is clear to this. I want you all to revisit a formula or a property like this. Integral of 0 to 2a can be written as integral of 0 to a f of x plus integral of 0 to a f of 2a minus x dx. Is it there? Check this property. So integral of 0 to 2a will come. You have it in the text. This property is there. So 0 to 2a f of x dx can be written as 0 to a f of x dx plus 0 to a f of 2a minus x dx. Now, why I used it is, in the previous step that I have I dash is equal to half of integral of, observe this, 0 to pi log of sin t dt. Do I have this? Now, in this case, this pi is there. That pi is my 2a. So 2a and pi are same. So what I will do is I will write I dash is equal to half into integral of 0 to pi. So what is the property telling? You have integral of 0 to 2a. On the right hand side, you change the limit from 0 to a, which is exactly half of 2a. So 0 to pi log of sin t dt plus integral of 0 to pi log of sin pi minus t dt. Are you able to understand what I mean? So I dash will be equal to half into integral of 0 to pi log of sin t dt plus integral of 0 to pi log of the sine of pi minus t. I will still write it as sin t dt. Here. So I dash should be equal to half into 2 times integral of 0 to pi log of sin t dt, where this 2 and 2 will get cancelled, and according to property number 1, I can write this as 0 to pi log of sin x dx. So if I take this as 2, then using 2 in 1, what am I going to get? I is equal to, in 1 if you see, 2i is on the left hand side is equal to, this is I dash. So what is I dash actually equal to? Log of sin x dx. But log of sin x, so 1 minute, one small correction. Here I need to make it as pi by 2. What you guys observe. 0 to pi, when I write it on right hand side, the upper limit should become half of 2a, no? So when pi is 2a, half of 2a is pi by 2, no? So it will be pi by 2, pi by 2. Here also it is pi by 2 and pi by 2. So 2i will be equal to, if you observe what this is, it is the question. It is I itself. So is this not the question? 0 to pi by 2 log sin x. That is what I consider to be I. Right? I minus, what do I have here? 0 integral of 0 to pi by 2 log 2 dx. Is it right? So if this I comes to the other side, it becomes I is equal to minus of log 2 into integral of dx between 0 to pi by 2 will give me pi by 2. So the answer is minus pi by 2 log 2. Okay, so that is the required answer. It is slightly lengthy, but it is a very important. Okay, mark it as important. I hope concept is clear. Those who are online, could you understand?
Yes, sir.
The same thing, no? Repeated. Sorry, oh, we are done with this. So this is the last example. You remember what I did last week for online class when I took on Monday? Who all attended last week on Monday? Huh? That is the level of irritation I get. Last Monday, I didn't even say anything. I just cut the call and left. Remember? Level of irritation. That's what people are doing. You move to call cut it. Not even bother. Sitting at home and sleeping. Good. So integral of 0 to pi by 2 cos square x dx. So if I take this to be I, it's a simple problem. I is equal to integral of 0 to pi by 2 cos square x dx. So I will be equal to integral of 0 to pi by 2 cos square of pi by 2 minus x dx. So it will be integral of 0 to pi by 2 sin square x dx. So when you add both, you will get 2I is equal to integral of 0 to pi by 2 cos square x plus sin square x dx. Right? So this will be equal to integral of 0 to pi by 2 dx. So 2I is equal to this much value means 2I will be equal to x, which is pi by 2. From here I will get I is equal to pi by 2.
Sir,
Tell me that.
sir, I don't understand how do I
Did you attend
is
yesterday's
equal
class?
to cos square x plus sin square.
Did you attend yesterday's class?
No, sir.
Yes or no?
No, sir.
You have to go through that because I can't explain the concept again. So what is the property number of P4?
Okay, sir. I got it.
Integral of 0 to a, there is some property like this. Integral of 0 to a f of x dx, P4 only, no? It is integral of 0 to a f of a minus x dx. Means wherever I have x, I can replace it with a minus x. That is why I wrote it as pi by 2 minus x. This is property B4. What is the page number in textbook? 341. Ram, go to page 341 and look at this property. and go through the concepts of yesterday's class in detail.
Okay, sir, I understood.
Shall I proceed? So this one, there's also something similar to what we did yesterday. So I is equal to integral of 0 to pi by 2 root sin x divided by root sin x plus root cos x dx. So I will be equal to integral of 0 to pi by 2 root of sin of pi by 2 minus x divided by root of sin of pi by 2 minus x plus root of cos of pi by 2 minus x dx. Right. So what will happen from here? I can say I will be equal to integral of 0 to pi by 2 root of sin pi by 2 minus x is root cos x divided by root cos x plus root sin x dx. So when I add both, when I add this integral and this integral, what do I get? 2I is equal to integral of 0 to pi by 2. So it is going to be root sin x plus root cos x divided by root sin x plus root cos x dx. So what is going to be the answer? 1. So 2I will be equal to integral of 0 to pi by 2 dx, which implies 2I is equal to pi by 2, which implies I is equal to pi by 2. Right. So this problem is, third one is similar to second. So this one is homework. You can try. So third one is similar. Fourth one is also similar to second. Fifth one I'll do it. So I want you all to concentrate. This is also an important one because there is a problem based on modulus. Okay. So when I have integral of minus 5 to 5 mod of x plus 2 dx, then f of x will be equal to mod of x plus 2. Right. Then f of x will be equal to x plus 2 when x is greater than minus 2. Okay. It is 0 when x is equal to minus 2. And it is minus of x plus 2 when x is less than minus 2. That is what the modulus function is. So here, if you observe, when I take from minus 2 to, so what do I have on the number line? Minus 5, minus 4, minus 3, minus 2, minus 1, right? 0, 1, keeps on going like this. So from minus 5 to minus 2, okay? From minus 5 to minus 2, what should I take the value as? Minus of x plus 2 dx plus. From minus 2 to 5, what should I take the value as? I should take it as x plus 2 dx. Do you understand why? Because when x is less than minus 2, when x is less than minus 2, where is the limit stopping? Less than minus 2, where is the limit stopping? Starts at minus 5. So minus 5 to minus 2. When x is less than minus 2, what is the function? It is minus of x. So that's right. Right. So again, where is this limit likely to start from? This minus 2. And where is it stopping? Stop at 5. So when the value of x is greater than minus 2, it is x plus 1. That's right. Understood? So now this part I'm assuming that you can integrate. Can you? This part you guys can integrate. That part I'm leaving it to you. Okay. So from here onward, it is left to you to solve. Okay. So you have to write. It's recorded. Shall I proceed? Concept is clear, right? Can you guys try this? So whenever you have a modulus function, first step is define the modulus function, elaborate. What is the answer? 9. Integral of 0 to 1 x into 1 minus x the whole power n. Okay, if I call from this, what I can say is I is equal to integral of 0 to 1 1 minus x into 1 minus of 1 minus x the whole power n dx. Did you understand what I did? I did integral of 0 to a f of x dx is equal to integral of 0 to a f of a minus x dx. Right. So integral of 0 to 1 1 minus x into x power n dx. So wherever x is there, I need to substitute 1 minus x. Right. Now what will you get? Integral of 0 to 1 x power n minus x power n plus 1 into dx. So integral of 0 to 1 x power n dx minus integral of 0 to 1 x power n plus 1 dx. So this will be x power n plus 1 by n plus 1 between 0 to 1 minus x power n plus 2 by n plus 2 between the same 0 to 1, which implies it is 1 by n plus 1 minus 1 by n plus 2. So you get the answer as 1 divided by n plus 1 into n plus 2. This is the answer. Is it clear? Take LCM and then solve. We have n plus 2 minus n plus 2. N plus 1 into n plus 2. Clear? Shall I proceed? Copy. Yeah. So integral of 0 to pi by 4 log of 1 plus tan x dx. So if I take this to be I, the same I is equal to integral of 0 to pi by 4 log of 1 plus tan of pi by 4 minus x f of a minus x property. So I will be equal to integral of 0 to pi by 4 log of 1 plus tan pi by 4 minus x is 1 minus tan x by 1 plus tan x. Am I right? Yes. So when I take LCM and then solve 0 to pi by 4 log of, it will be 2 divided by 1 plus tan x dx. So when I take LCM, tan x and tan x in the numerator will get cancelled. I'll be left out with 2 divided by 1 plus tan x. Here. So this will be equal to integral of 0 to pi by 4 log 2 minus integral of 0 to pi by 4 log of 1 plus tan x dx. Am I right? Observe this. Am I right? So this is 1, this is 2. So I'll do it here. When I add both, 2i will be equal to what will get cancelled? 0 to pi by 4 log of 1 plus tan x and log of 1 plus tan x will get cancelled. So what I left out with 0 to pi by 4 log 2 dx. So 2i will be equal to log 2 into integral of dx is x between 0 to pi by 4. So 2i will be equal to pi by 4 log 2 or I will be equal to pi by 8 log. Is it clear? Shall I proceed? So integral of 0 to 2 x into root 2 minus x dx. Same logic. This I'll call it as I equation number 1. So I will be equal to integral of 0 to 2 minus x into root of 2 minus of 2 minus x dx. So I will be equal to integral of 0 to 2 minus x into root x dx. Now it is easy to solve. So this will be integral of 0 to 2 root x dx minus integral of 0 to 2 x power 3 by 2 dx. So I will be equal to 2 into integral of root x will be equal to x power 3 by 2 by 3 by 2 minus this will be x power 5 by 2 by 5 by 2. So they are acting between the limits 0 to 2 and 0 to 2. So this will be equal to this 3 by 2. You take the reciprocal, it will become 4 by 3 into substitute the upper limit. So it becomes 2 power 3 by 2 minus 0 minus this is 2 by 5 into substitute the upper limit. 2 power 5 by 2 minus 0. Right. So you will have 4 by 3 into 4 by 3 into 2 root 2 minus 2 by 5 into 4 root 2. So if you take out root 2 common, you will have 8 by 3 minus 8 by 5. Okay. So when you solve this, you will get the required answer. So it will be root 2 into, or I can take 8 also outside, it will be 2 divided by 15. So 16 root 2 divided by 15 is going to be the answer. This one, 10th one, if you see integral of 0 to pi by 2 log sin x minus integral of 0 to pi by 2 log sine 2x dx. Remember? So in that example problem that I did, we got this in one of the intermediate steps, 0 to pi by 2 log of sine 2x dx. Then what did we do? We took 2x is equal to t, and then we proceeded. So when you did this, you got this to come out as integral of 0 to pi by 2 log sine x dx. You remember that? Right. So this will be integral of 0 to pi by 2 times log sine x minus integral of 0 to pi by 2 log sine x dx. So this will be equal to integral of 0 to pi by 2 log sine x dx. Right? 2 log sine, sorry, 2 log sine x minus log sine x. And this value, when you integrate according to the example, so you should not do it directly like this, okay? You have to show them separately. So when you do this, you will get minus pi by 2 log. Understood? Huh? But only thing is, when this question comes in exam, you need to do it in an elaborate way. Integral of minus pi by 2 to pi by 2 sine square x. What is it? So you have this property, integral of minus a to a f of x dx is equal to 2 times integral of 0 to a f of x if f of x is even. It is 0 if f of x is odd. You have this property. So if I look at this I can write it as, if I take sine square x is an even function because I have a square. So I'll get this thing. So 2 into integral of 0 to pi by 2 sine square x dx. This is what is I. The same I can be written as 2 into integral of 0 to pi by 2 sine square of pi by 2 minus x dx. So which will be cos square. So 2 into integral of 0 to pi by 2 cos square x dx. So when I add both, I'll get 2i is equal to 2 into integral of 0 to pi by 2 sine square x plus cos square x dx. Okay. So 2 and 2 will get cancelled, which implies I is equal to integral of 0 to pi by 2 dx. Answer will be pi by 2. Sure. How many problems are there? So I is equal to integral of 0 to pi x dx divided by 1 plus sin x. The same I can be written as integral of 0 to pi minus x dx divided by 1 plus sin x. Is it clear? So when I add both, I'll get 2i is equal to integral of 0 to pi. X plus pi minus x will be pi. So pi dx divided by 1 plus sin x. Okay. So this will be equal to pi into integral of 0 to pi dx divided by 1 plus sin x. Correct? Did you understand what it is? So integral of 0 to a f of a minus x dx. So in the place of x, I put pi minus x dx. 1 plus sine of pi minus x sin x. So when I added these two, I plus I is 2i divided by, so 2i will be equal to integral of 0 to pi, x plus pi minus x is pi, so pi dx divided by 1 plus sin x. So this will be equal to pi into integral of 0 to pi dx by 1 plus sin x. Right. Now, integral of 0 to pi 1 by 1 plus sin x. How should I? How to solve this? So I have to eliminate the denominator. So think if you can do something with integral of 0 to a. You have this property, integral of 0 to 2a, f of x dx is equal to, can we do that? Because see, there is 2a. So I can write integral of 0 to pi by 2. So, but will I get the answer 1 by 1 plus sin x plus 1 by 1 plus cos x? It's not going to generate any useful result for me. So 2i, I can write it as pi into integral of 0 to pi dx divided by, this I can write it as sin square x by 2 plus cos square x by 2 plus 2 sin x by 2 cos x by 2. When I do this, I get sin x by 2 plus cos x by 2 the whole square. Am I right? So I get 2i is equal to integral of 0 to pi dx divided by, I'll write cos x plus sin cos x by 2 plus sin x by 2 the whole square. So shall I take the cos x outside or cos x by 2 outside? So it becomes 2i is equal to integral of 0 to pi dx divided by cos square x by 2 into 1 plus tan x by 2 the whole square. See, what it is. When I take this cos x by 2 outside, it comes as cos square x. But I have to divide the cos x by 2 to compensate the sin x by 2. So it becomes 1 plus sin x by 2 by cos x by 2 is tan x by 2. So this will be equal to 2i implies integral of 0 to pi secant square x by 2 divided by 1 plus tan x by 2 the whole square. So what is 1 plus tan x by 2? I'll take it as t, which implies secant square x by 2 into half into dx is equal to dt. When you put x is equal to 0 here, what will you get? T will be equal to 1. When you put x is equal to pi, t will be equal to infinity. So what will happen? 2i will be equal to integral of 1 to infinity secant square x by 2 dx is 2 dt divided by t square. Did you understand what I did? Did you understand what I did? So 2 and this 2 will get cancelled, which implies I will be equal to integral of 1 to infinity dt by t square. Integral will be so I will be equal to minus 1 by t from 1 to infinity. But what is t? So minus 1 by infinity minus of minus 1. So what will I get? I will get plus 1. So I is equal to 1. Is that the answer? Which one? What is the total? 12. 5. ಎದುರಾ? Check. No, but x is equal to pi. Correct, then. See, 1 plus tan x by 2, I took it as theta. So secant square x by 2 into half dx is equal to dt. So secant square x by 2 is equal to 2 dt. Okay. So 2 dt divided by t square. So integral of 1 by t square is minus 1 by 2. Minus 1 by t from 1 to infinity is going to be. Did I miss something? So let's come from the beginning. Let's check it first. Integral of 0 to pi x is divided by 1 plus sin by 2. So both added. Did you understand what is there here? And this is the pi here. So this whole thing multiplied with pi will give me the answer as well. Pi is the answer. That's what it is. What a doubt does not get answered. Okay. Go. One last problem and we'll end this. Answer. Right? What function? So remaining problems, I'm expecting you to solve it. And you have any doubt, so next class I won't go. Okay. I'll be starting areas of applications of integrals. So from next class, we'll have applications of integrals. That is maximum 2 classes. Then differential equations. Take some time. 3 to 4 classes. So I'll calculate and let you know. As I told you yesterday, I'll be planning some extra classes also for because I have to complete it by October. November, then I want to start the revision. I've already put the schedule. No, at a new paper you can't attend. Okay. So I will work accordingly. I'll let you know. But I'm not going to do integrals anymore. Starting from Monday, it is going to be applications of integrals. And I'm giving you a warning for you to understand and solve problems in applications of integrals. You need to master all these properties. So it's better you practice and come to class. So yeah. Any other doubts? That's it, no? We'll wind up.